All right, folks, it's back in action here. In this video, we're going to look at using the inverse method to solve a system of two variables. Now, we are not going to use the inverse method for any systems of equations beyond two variables. That's beyond the complexity of this course. Finding the inverse of a 3x3 matrix is more than what we want to do in here for our systems of three variables. In order to solve our systems of three variables, we're going to use a method called Cramer's rule, and we're going to look at that in the next video. So this is just going to cover our systems of two variables. Now, what I want to take a look at actually is the bottom of this before I get into the details of a specific problem. So down here at the bottom, on the bottom left, I have the process written out in words so we can kind of follow along with what's going to happen here. What we're going to do is we're going to take our inverse matrix times the original coefficient matrix that we're going to start with for our system of equations. We've talked about coefficient matrices a couple videos ago. We know that if we multiply an inverse times its original matrix, we will get the identity matrix. So we can essentially eliminate the coefficients by multiplying them by the inverse. Now, what we'll do when we set up our problem is we will pull out and isolate the actual variables in the problem. So our xy will get pulled out. So after we multiply the inverse times the coefficients, we're left with just the variables on the left-hand side. So that's why our left-hand side is going to work out the way it does. We've already proven that an inverse times its original matrix will get the identity matrix, so I'm not going to work that side of the process when I work through my solution. On the right-hand side of this equation, we're also going to use the inverse matrix because remember, what we do to one side, we have to do to the other. So we're going to use this matrix, that inverse matrix, on both the left and the right. And on the right-hand side, we're going to multiply it by the constants, okay? So when I multiply the inverse matrix by the constants, that is actually going to give us our solutions. So that's just the repeat of the previous step, and then what we will have is our solution matrix. So I'm pretty much just going to work through this right-hand side, but we will do our initial setup up on the top and show how that's going to work. So let's go back up top and jump into a specific example and see how this is going to work. Again, we are only doing this with systems of two variables. We will not be doing this with anything beyond that. It's also important to remember that not all matrices, square matrices, will have an inverse. So if you try to jump into this process and you find that that matrix does not have an inverse, this method is no longer available to you, so you would have to use another technique. All right, so we've got our system of equations that we want to solve here. So here's my system that I want to solve. A couple videos ago, we talked about coefficient matrices and we talked about an augmented matrix. And here's where we're going to use our coefficient matrix. So what I'm going to do is, this is what I talked about at the bottom. I'm going to write my coefficient matrix in this first box. So I've got my 8, my -3, my 5, and my 2. I said I was going to separate out those variables. And if this seems kind of weird, what you can do is you could go through and multiply this. And if you multiply this out, you'll actually get back to this entire expression here. You'll end up with an 8x and a -3y and a 5x and a 2y. So it just allows us to separate it out to do our work a little better. On the right-hand side, we're going to write our constants. So basically, it looks like the regular system of equations. We've just pulled out the x and the y. Now what we're going to do is we're going to find the inverse of the coefficient matrix. So just the coefficient matrix here. So this gives us a chance to practice that formula that we did on the previous video. So remember, we first have to find our determinant. And when we do our determinant, remember it's this product minus this product. Just reviewing that. So because we only did one example on the previous video. So we've got an 8 times 2. And we're going to subtract our -3 times our 5, which means what we really have is our 16 plus a 15, or in other words, our determinant is 31, okay? Next, what we're going to do is continue finding the inverse, so that means that we have to take the reciprocal of that determinant. and we need to multiply that by our modified square matrix. Remember, our modified square matrix is going to reverse this first diagonal. So that's going to become a 2 and an 8. And then we keep the order of the other diagonal, but we change its sign. So it's going to become a -5 and a +3. When I distribute that scalar, this is going to look pretty bad, but don't worry, it all turns out pretty nice in the end. I get a 2 over a 31, I get a 3 over a 31, a -5 over my 31, and my 8 over my 31. So it looks pretty bad, but don't worry, it's going to turn out nice by the time we're done. So that is the inverse of the coefficient matrix, which means that if we took that and we took this inverse and we put it right here, and then we took our original coefficient matrix and we did that product, we'd get the identity matrix, okay? I'm not going to do that. I'm just going to work through this blue side over here. Now, what we're going to do is we're going to take that inverse matrix of the inverse of the coefficient matrix that we just found, and I'm going to write that one. So I'm going to have my 2 over 31. I'm going to have my -5 over 31, my 3 over 31, and my 8 over my 31. And then I'm going to multiply that by those constants that I had up above. That was a 50 and an 8. And now I can start doing my multiplication. So that means I'm going to do my 2 times my 2 over 31 times my 50, and my 3 over my 31 times my 8. When I do that, what I'm going to get, and I'm going to write a middle step. Sometimes you'll need it and sometimes you won't. That's going to give me a 100 over 31 plus my 24 over my 31. And then I'm going to do the next row, which will be my -5 times my over 31 times my 50, and then my 8 over 31 times my 8. And that's going to give me a -250 over 31 plus a 64 over a 31. And you'll notice we already have our nice common denominators, so that makes our life a little bit easier. So when I add those together, my 100 over 31 plus my 24 over 31, when I add those together, that's actually just going to simplify very nicely down to a 4. My -250 over 31 plus my 64 over 31 is going to simplify very nicely down to a -6. So what we're saying is that our 4 and our -6 equals our x and our y. So now we can easily read our solution as 4, -6. And I would suspect that a lot of you, would prefer this method over the row operation method that we used in our last lesson.